Alright, let's look at our test review. Looking at number one, I have to make a common denominator. So this is x over 1. So to get a common denominator of x minus 7, we need to multiply by x minus 7 in the numerator and the denominator. So this is going to become x squared minus 7x over x minus 7. And then we've got plus x minus 5 over x minus 7, and that's equal to 10x plus 60 over x minus 7. So now we've got common denominator in all of those. Alright, so I've got x squared minus 7x plus x minus 5. And I'm going to move this to the other side, so this is going to become a minus 10x. So we've got x squared minus 7x plus x minus 5 minus 10x minus 60. And now we're all over the same denominator of x minus 7. So all I did was move that to the other side and make it equal to 0. Now we can combine like terms. So we've got x squared. We've got a negative 10x, a negative 7x, and a positive x. That's going to be negative 16, negative 16x. And then we've got a negative 65, negative 16, negative 5. Alright, so now we can look to factor this if possible. It's not factorable, so we're going to go ahead and work the quadratic formula. So I've got opposite of b, so I've got 16 squared plus or minus the square root of 16 squared minus 4 times 1 times negative 65 over 2 times a, which is 1. Alright, now for the sake of time, I'm just going to tell you it's going to be 16 plus or minus the square root of 5, 16 over 2, and that's equivalent to 19.36, or if you do the minus, you would get negative 3.36. Because again, plus or minus, you have two cases here. Alright, looking at number 2, it says what are the solutions to my equation? Alright, so once again we need to find a common denominator. So let's multiply this side by x, this side by x minus 1. So we've got x squared plus 2x is equal to 2x squared minus 2x plus 4x minus 4. And these are over the same thing. Alright, now once again I'm going to get these on the same side so I can get it equal to 0. So I'm going to subtract this x squared. That's going to become positive x squared. I'm going to subtract this 2x. So negative 4x, but a positive 4x, that's going to cancel out. So you've got minus 4 at the top, and that's over x minus 1. Alright, that's equal to 0. So now when we multiply these, bam, that goes away. So we get x squared minus 4 equals 0. Plus 4 plus 4. Take the square root of 4 and we get x equals plus or minus 2. Always check your solutions to make sure they're not extraneous. I'm not going to do that because that'll take forever. Alright, looking at number 3. Okay. Again, I want to find a common denominator. So the common denominator that I got was y, 8y plus 2. So I'm going to multiply this by y. Multiply this by 8y plus 2, so this is going to become y squared plus y over y 8y plus 2 plus 3 times 8y plus 2 over y 8y plus 2. That's equal to 5/3. Alright, so now once again I've got y squared plus y. I need to multiply these, distribute. So I get y squared plus y plus 24y plus 6 over y 8y plus 2 equals 5/3. Alright, now I can combine like terms and I get y squared plus 25y plus 6 over y 8y plus 2 equals 5/3. Alright, now what I did is I cross multiplied here, so let's go. I get 3y squared plus 75y plus 18 is equal to 5y 8y plus 2. Now again, we're going to get our like terms on the same side, and we'll need to use quadratic formula. I'm going to tell you right now, for the sake of time, y equals 2 and negative 9 over 37. Alright, looking at number 4. Again, need to find a common denominator. So first and foremost, I'm going to multiply this one by 2. So I got x plus 7 over 4 minus 2x plus 2 over 4 is equal to 5 minus x over 3x minus 14. So I've got x, negative x, and then I've got 7 minus 2 is going to give me positive 5 over 4 equals 5 minus x over 3x minus 14. Alright, now I've got two options. I'm going to go ahead and cross multiply here. So this is going to be 20 minus 4x is equal to negative x plus 5 times 3x minus 14, which if you FOIL that out, you get negative 3x squared plus 14x plus 15x minus 14 times 5, 20, 70, minus 70. Alright, so we've got 20 minus 4x equals negative 3x squared plus 29x minus 70. Alright, so let's move our 20 to the other side. So we're going to subtract it, minus 20 on both sides. And let's move the 4x, add 4x. So we get negative 3x squared, and we get positive 32x, and we get negative 90. Now once again, we look to factor this if we can. Not, we use quadratic formula. Again, quadratic formula, we plug it in. Okay, and we get x equals negative 33 plus or minus square root of 9, which is 3. So I'm going to go and write 3 over negative 6. Okay, so we've got two cases. We've got the positive case and the negative case. Negative 30 on top if we add. Divided by negative 6 is a positive 5. If we subtract, we get negative 36 over negative 6, which is a positive 6. So x equals 5 or x equals 6. And again, check me for extraneous solutions. Alright, let's skip number 5 and let's get going on some graphing. Let's look at number 6. So number 6, okay, I can see that my transformations here, I have a negative in front, so it's going to be a reflection over my horizontal asymptote. I moved to the right 3 and I went down 2. So we have a reflection over horizontal asymptote. I went right 3 and I went down 2. So if I go right 3, that means my intercept, my asymptote, excuse me, my vertical asymptote is going to be at x equals 3. If I went down 2, that means my horizontal asymptote is going to be at y equals negative 2. Alright, so now we have that set up. Now I have a reflection over the horizontal axis, so instead of being the top right quadrant and the bottom left quadrant, it's going to reflect over the horizontal asymptote. So this one's going to go down here, and that one's going to go up here. So my graph, okay, sketch, a rough sketch would look something like this. So I know now that when I'm identifying my domain and my range, my domain is going to go from negative infinity to my vertical asymptote, so negative infinity to 3, union with 3 to infinity. And my range is going to go from negative infinity to my horizontal asymptote at 2, union with 2 to infinity. Is it symmetric? It's neither odd nor even. Okay, is it increasing or decreasing? It is an increasing function, excuse me, because we had a reflection over the horizontal axis. And when I write it in my intervals, we use my domain because it's increasing across both intervals. There are no holes, nothing canceled out in the numerator and the denominator. Let's look at my end behavior. So as x approaches negative infinity, we're getting closer and closer to the horizontal asymptote at 2. As x goes to positive infinity, same thing, we're getting closer and closer to the horizontal asymptote. But now as x approaches my vertical asymptote at 3, we have to examine it from the negative side and from the positive side. So from the negative side, coming from the negative values, it's going to positive infinity. And coming from the opposite side, coming from my positive values, it's going to negative infinity. Alright, now good little hint there. Okay, this will always be flipped. So if I'm looking at the negative side, if I have a reflection, okay, I'm going to positive infinity. If there was no reflection, if I was going from the negative side, it would go to negative infinity. So the negatives would be the same. Unless I have a reflection, it would flip my end behavior. Alright, let's look at my intercepts. Okay, my intercepts, if I plug in 0 here, I've got negative 1 over negative 3, so positive 1/3 minus 2. We would get our intercept of negative 5/3. And my other intercept is going to be at 5/2, 0. All I'm doing is set this equal to 0. So I've got 0 over negative 1 over x minus 3 equals 2. So I'm going to move the 2 to the other side, so it's going to become a positive 2. Now I need to multiply this by 2, right? So 2 times x minus 3 and 1 times negative 1. So negative 1 equals 2x minus 6. We're going to add 5 to both sides. Add 6 to both sides, excuse me. And we get 5. We divide by 2 and we get 5/2. That's where I got that from. Alright, looking at, we can go to number 7. Looking at number 7. Alright, from the looks of it, okay, looks like I have a vertical stretch here, but let's go ahead and factor out our 2 out of the denominator. So this is going to become 2 over 2x plus 2 minus 1. Now this 2 over 2 reduces, right? We want to write it in its simplest form, so g of x is equal to 1 over x plus 2 minus 1. So what transformations took place? We went left 2 units, opposite of that number, and then we went down 1. Alright, so let's look at our asymptotes, right? We went left 2 units, that means my vertical asymptotes at x equals negative 2. And if we went down 1, that means my horizontal asymptote is going to be at y equals negative 1. Domain, okay, my domain is going to go from negative infinity to my vertical asymptote of negative 2, union with negative 2 to infinity. And now the range is going to be the opposite. We're looking at my horizontal asymptote, so we're going to negative 1. Now there was no reflection, so once again, just a rough sketch, right? Looks like this. Alright, something like that. Alright, so is it symmetric? Again, plug in negative x for my x value, and if you get the same equation, it is even symmetry. If you get the inverse equation, it's odd symmetry, and it's neither in this case. Is it increasing or decreasing? Okay, there was no reflection, so it's a decreasing function, again, over my interval from negative infinity to negative 2, union with this other interval from negative 2 to infinity, because they're both decreasing. Holes, there are none in behavior, so as x approaches negative infinity, we're getting closer to my horizontal asymptote at negative 1. As x approaches positive infinity, same thing, we're getting closer to my asymptote at negative 1. As we're looking at my vertical asymptote, so as x approaches negative 2 from the left, and as x approaches negative 2 from the right, right? So as it approaches it from the left, we're going to go to negative infinity. That's what I was saying earlier. And the other way, we're going to go to positive infinity. So positive should be positive, negative should be negative, unless we had some type of reflection. The intercepts, once again, we can plug in 0 here. We get 2 over 4, which is 1/2 minus 1. We get negative 1/2, so 0, negative 1/2. My other intercept is going to be negative 1, 0. And those are the 2 intercepts. Alright, let's go on to our word problems. Looking at number 9. Number 9, it says working together. It takes Sam, Jenna, and Francisco 2 hours to paint one room. When Sam works alone, he can paint a room in 6 hours. When Jenna works alone, she can paint a room in 4 hours. Determine how long it would take Francisco to paint one room on his own, right? So we have working together, it takes them 2 hours to paint a room. So we have Sam, Jenna, and Francisco equals together, right? So together we're going to paint one room in 2 hours. Francisco is what we're looking for, right? We know Jenna is going to be, she can paint one room in 4 hours, so 1 over 4. Okay. Sam can paint 1 over 6, excuse me. And then Francisco is going to be 1 over, and we don't know the rate. We don't know how long it takes him, the time, excuse me. Alright, so we got this equation right here. Once again, let's find a common denominator. So in this case, I'm going to find a common denominator of 24x. So this needs to be multiplied by 4x. So this is going to become 4x over 24x plus This needs to be multiplied by 6x, so plus 6x over 24x. This can be multiplied by 24, so plus 24 over 24x. And I'm going to move this to the other side, so that's going to be minus. That needs to be multiplied by 12x, so minus 12x over 24x, and that's equal to 0. Alright, so I've got 6 plus 4 is going to be 10, minus 12 is going to be negative 2x plus 24 over 24x equals 0. That's going to cancel out, so I've got negative 2x plus 24 and equals 0, so you're going to solve, and we get x equals positive 12. So 12 hours, right? It takes them 12 hours to paint a room. Alright, it says Melissa walks 3 miles to the house of a friend and returns home on a bike. She averages 4 miles per hour faster than cycling than when walking. Total time for both trips is 2 hours. Find her walking speed. Alright, so trip there, right? So the trip there, she's going to her friend's house. She's going to walk 3 miles. She returns home on the bike, right? So we got trip, time for the trip walking there, plus the time for the trip coming back is going to be equal to 2 hours. Alright, now what's the time? Alright, well, let's go. Distance equals rate times time. We know the distance is going to be 3 miles. We don't know the rate, so we're going to plug in x. And we're going to set my proportion of d over r, or I could say x, is equal to t, right? Distance over rate is equal to the time. Well, we want to find the time that it takes for her first thing. Okay, so I'm going to plug in the distance. She's going 3 miles over the rate, which was x plus 4. Why is it x plus 4? Because she averages 4 miles per hour faster cycling than when walking. Alright, so 3 over x plus 4 plus 3 over x is equal to 2 hours, right? The time, this is the ratio for time. I did distance over rate. This is the ratio for time. I did distance over rate. This is trip going there. This is trip this is trip going there. This is trip coming back. That's equal to 2 hours. Alright, now once again we're trying to find a common denominator, so we're going to multiply this by x plus 4. So I've got 3x plus 3x plus 12 over x plus 4 is equal to 2x plus 4. Right, and find a common denominator here. Alright, we can combine like terms. We get 6x plus 12 equals 2x squared plus 8x. Alright, so now let's subtract these. So I got 2x squared positive 2x negative 12. Back to our GCF, so 2. We get x squared plus x minus 6. It's going to become 2x plus 3x minus 2. Alright, so we get x equals negative 3 and positive 2. Now, which one makes sense, right? We're talking about her walking speed. Does negative 3 make sense for a walking speed? Absolutely not. So we're looking at 2. X equals 2. So her walking speed, 2 miles per hour. Alright, looking at number 11, Sandra can paint a kitchen in 6 hours. Roger can paint the same kitchen in 7 hours. How long will it take for them, both of them, working together, right? So again, we're painting one kitchen in 6 hours. Roger can paint the same kitchen in 7 hours. How long will it take for both of them working together? We know if they're working together, we're going to add these two together. So one kitchen, 6 hours. Okay, and I've got the same thing over here. I've got 1 over 7, and that's equal to, if we're both working together, one kitchen in X amount of hours. So let's find a common denominator. Multiply this by 7, multiply this by 6. So I've got 7x plus 6x minus 42. Right, so all I did was multiply this by 7x, multiply this by 6x, multiply this by 42 to find a common denominator of 42x. That's equal to 0. I move that to the other side. Now once again, these are going to cancel out, so I've got 13x minus 42 equals 0, and I get x equals 42 over 13, or about 3.23. Last one, it says it takes a sink 10 minutes to fill up with water. The drain will empty the sink in 12 minutes. If Miss Mesa's child forgets to close the drain, how long will it take to completely fill the sink with water? Right, so we've got 1 over 10 minus, because we're subtracting the drain, equals 1 over x. All right, so once again, multiply this by 12x, this by 10x, and this by 120. Find my common denominator, so I've got 12x. And I've got 10x. So minus 10x. I'm going to move this to the other side, so minus 120. And my common denominator is 120x. That's equal to 0. All right, so I can combine like terms here. I've got 2x minus 120. When I multiply this, cross multiply, this becomes 0, so it's still equal to 0. So 2x equals 120, x equals 60 minutes.